We need to move towards a more secure energy future. The road to energy independence runs right through Grand Forks, North Dakota. Runs right up to the front door of the EERC.
Through the National Center for Hydrogen Technology, or NCHT, the Energy and Environmental Research Center at the University of North Dakota is developing practical systems that can produce energy from hydrogen. To accomplish this, the NCHT is researching systems that can ensure a hydrogen supply from fossil fuels like coal, oil, and natural gas, and biomass.
Not only do we add great value to the intellectual capability and commercial opportunities for new technology in this country, and indeed the world, but we also bring a lot of new high-quality jobs to this region.
Hydrogen is plentiful on Earth, but it occurs in combination with other elements. For example, hydrogen occurs with carbon in plants and fossil fuels. These materials that contain carbon and hydrogen atoms are called hydrocarbons. Water also contains hydrogen atoms. Coal is a fossil fuel that can be used to produce large volumes of hydrogen. The western coals, including the rich lignite resources in Texas and in the northern Great Plains, are especially good sources of hydrogen. Gasification is the process currently used to convert lignite coal to a hydrogen-rich gas at the Great Plains Synfuels plant in western North Dakota. The National Center for Hydrogen Technology is working with a number of industrial partners to pioneer the analytical and modeling techniques needed to develop future power plant systems that will use hydrogen from coal.
The NCHT focuses on the development of technologies and innovations to improve the overall systems and make new technologies so that we can get a hydrogen economy that takes advantage of the environmental benefits as well as drives down costs so it's more cost effective.
The NCHT is using its expertise in hydrogen systems to team with Air Products, a world leader in hydrogen supply, to develop an improved system for producing hydrogen from coal. This partnership will develop technology to produce a high-purity stream of coal-based hydrogen gas that can be readily used in turbines, engines, and fuel cells.
Air Products is working with EERC in North Dakota to look at potentially groundbreaking ways to harness the hydrogen that's embedded in coal and turn that into hydrogen that can be used, as I said, for purposes of powering vehicles or stationary sources.
The NCHT is also involved in enhancing engines, turbines, and fuel cells to use hydrogen efficiently. Natural gas turbines are currently being used to generate electricity. The National Center for Hydrogen Technology is teaming with Siemens Power Generation to help develop the next generation of turbines that will use hydrogen fuel and catalytic combustion systems to reduce emissions. The NCHT is developing and testing the effectiveness of these catalytic systems. Hydrogen-fueled turbines are operated at higher temperatures to make them more efficient. The EERC is working with Siemens Power Generation to develop high-temperature materials that can be used to make key components for industrial turbines, allowing them to operate on hydrogen fuel. To work well, fuel cells need a high-quality source of hydrogen. The National Center for Hydrogen Technology is meeting this need by determining specifications for the purity of hydrogen made from coal for use in solid oxide fuel cells. Different types of fuel cells have tolerances for different impurities in the fuel, and the solid oxide fuel cell is most efficient with very low levels of sulfur in the fuel. The Energy and Environmental Research Center is testing hydrogen use in specialty fuel cell vehicles like forklifts and neighborhood electric vehicles, and with piston engine on-road vehicles designed to utilize hydrogen as well as conventional liquid fuels. The NCHT worked with key commercial partners, including ePower Synergies Incorporated and Resurfice, to develop the first commercially available fuel cell-powered ice resurfacer. The hydrogen fuel cell eliminates the harmful exhaust gases left by ice resurfacers that use conventional fossil-fueled internal combustion engines. The ePower Ice Bear is on the market today and available for use on ice rinks worldwide. The National Center for Hydrogen Technology has partnered with the U.S. Army Engineer Research Development Center, ePower Synergies, and the U.S. Air Force to develop a dependable system that makes hydrogen on demand for hydrogen fuel cell powered vehicles. The system and the fuel cell vehicle are currently being evaluated by the North Dakota Army National Guard and Grand Forks Air Force Base. By working with government and industry partners today, the National Center for Hydrogen Technology is helping to build the sustainable hydrogen economy of the future.
Given the situation we have in this country with respect to energy insecurity and energy dependence, we need to focus a great deal of effort, and the ERC is taking the lead in doing that, in developing new and better technologies to extract it and utilize it in fuel cell applications and even in internal combustion engine applications.
To learn more about hydrogen and the National Center for Hydrogen Technology's full range of hydrogen programs and outreach activities, visit the EERC website at www.undeerc.org.
Funding provided by the U.S. Department of Energy, the North Dakota Division of Community Services, and the members of Prairie Public.